Hey guys, this is 7.1. It's called Radicals and Radical Functions. So we have finished what we're going to cover of chapter 6, and the rest of the unit is on chapter 7. So we're going to do 7.1, 7.3, 7.4, 7.5, and then we're done. All right, so I know we all know what a radical is, right, in general. And today we're just going to look a little bit more in depth about radicals and their functions, so you feel very confident. Okay, so a square root is the opposite of squaring a number, right? So this is a squared, and this would be the square root of b. If a squared is equal to b, then the square root of b is equal to a, okay? So they say the inverse, which means the opposite. The inverse is the opposite, and I want you to think about inverse like multiplication is the inverse of division. So if I'm multiplying something and I wanted to undo the multiplication, I would divide, right? If I have a variable and it's like they are adding 5 to it, a plus 5, the inverse or the opposite of that would be to subtract 5 from that variable, right? So if I have x squared, the inverse of x squared would be the square root of x. Okay, that's an understood 2 right here, or you can write a 2 right here if you would like. Okay, so and a cube and a cube root undo each other, a square and a square root undo each other. Okay, so the inverse or opposite of squaring a number is taking the square root of a number. So this one is squaring. Just so we're clear, that one's squaring, and this is taking the square root. Yeah. What this says is the square root of b is equal to a if and only if a squared equals b. Okay. So for example, the square root of 25 is 5 because, or if and only if, 5 squared equals 25. Okay, so if I put the square root of 25 into my calculator will give me 5 because 5 squared is 25. We also know that negative 5 squared is 25, right? Because 2 negatives multiplied by each other make a positive. We call the positive one the principal square root. The principal square root of a non-negative number a is its non-negative square root. So non-negative just means positive. There are 2 square root answers, right? The square root of 25 is 5 and it's negative 5. It has 2 answers, but the principal answer or the main answer, the answer your calculator will give you, is the non-negative one or the positive one. Okay, so if you were taking the negative square root of a, you would put the negative out in front of the square root symbol. Okay, so just to be clear, let's not do 25. We've done that. The square root of 9 is 3, right? Negative square root of 9 is negative 3. Okay, but if you remember, we cannot ever put the negative under the radical, right? If I did this, it gives me a non-real answer and it's an error. There's no solution. Because there is no number that I can multiply by itself and get a -9. -3 times -3 is a +9. So -3 squared is +9. Three squared, we know, is 9. No two negatives, no two positives can equal a negative. Which is why we can never put a negative under the square root symbol. All right. So let's find each square root. Okay. What number squared for A? Well, let's remember that this is an understood 2. So we don't write it as 2. Anytime you see it and there's no number there, assume that it is a 2, okay? Because as we go on, we'll see some 3s. We might see some, 6, 5, and 4, okay? But if there's nothing, it's always a 2. Good? So we call it the square root of 49. It means a number times itself equals 49, or a number squared is 49, right? So what times what equals 49? 7, right? Because 7 times 7 is 49. We're going to use factor trees. I'm going to use factor trees. You are welcome to use your calculator. There's nothing wrong with that, right? But to solve some of these, it helps me to visualize it. So 49, two factors of 49 are 7 and 7. That means when I go across the factor tree, across this row of it, and I multiply, 7 times 7 is 49, or 7 squared is 49, okay? 7 times 7 is 49. All right. Oh, okay, this is what I was going to say. I forgot. So because this is a 2, we are looking for two factors that are the same, right? Just like over here, we said the square root of -3 is -3 times -3. So there are two factors to make up the 9. So the square root needs 2 3s, 3 times 3. The cubed root will need 3 factors, but this will always need 2 factors, okay? So 25 over 16, it's a fraction, but if I can square the top and the bottom, I will be able to find the answer. I don't have to treat it like a fraction. So the square root of 25, can you think of two factors of 25 that are the same number? 5 and 5, right? 5 times 5 equals 25. So the square root of 25 is 5, just like we did on the first slide. The square root of 16 is 4 and 4, right? So the square root of 25 over 16, the square root of 25 over 16 is 5/4. Remember, if the negative's out in front, we just pass it on. The square root of 4 is 2 and 2, right? So the negative square root of 4 is -2. The square root of 0.81. What times itself can give me a 0.81? I'm not super confident with decimals, right? There's not a lot of decimal work. that we've done in this class. It was a long time ago, right? So I know that if I just took the number 81, right, I could factor just 81. 81 would be 9 and 9, right? So I know it's going to be some kind of 9, but I don't know if it would be like 0.9 or 0.09. You can just put it in your calculator. The square root of 0.81 is 0.9. I could also say it's 0.9, either one. Okay. Letter E, we have 9x to the 10th. And again, these are all understood 2's. So 2 factors of 9. Is it blurry? This looks blurry. Two factors of 9 are 3 and 3, right? 3 times 3 is 9. So that will become 3. What about the variable? We can always break down the radicals using a factor tree because that means we multiplied these two to get that one, right? So what do we need to multiply to get x to the 10th? We don't know what x is, so the only thing we have are x's, right? To get x to the 10th, I multiply x 10 times, right? Put that last one over here. All right, so this is x to the 10th, a visual of x to the 10th. And remember, we want pairs. If we have a pair, we can move it outside of the radical, right? If you remember, the square root is the radical, sorry. So you call it the radical or you can call it the square root. So if I had like the square root of 32, yeah, that's not going to be a perfect square. 5.7, right? But I can use a factor tree and I can take something out because if I have 2 of them, because this is an understood 2, I'm looking for 2 of the same number and I can put it outside the radical. So for 32, I'm just going to make the factor tree. 32 can be divided into 16 and 2, right? I know that 16 over here has 2 factors that are the same, 4 and 4. So now, and if you note, every line of a factor tree, if you multiply it, you get your answer. So 16 times 2 is 32, or you get your top number. 4 times 4 times 2 is also 30. Yeah, you can also go 2 times 2 times 2 times 2 times 2 is 32. But here, I'm only looking for pairs because this is an understood 2. So the square root of 32 is 4 times 4 and 2. I can take the 4 out because it's a pair. So the 4 is now in front of the radical, but the 2 stays under the radical because there's only 1. So the square root of 32 is 5.65. And 4 square root 2 is the same. Okay. So where I'm looking for groups of 2, if I find groups of 2, I can pull them out. So here are 2 x's, right? How many groups of 2 x's can I get out of 10? It's 5, right? 1, 2, 3, 4, 5. So I can find 5 groups of x, so it's 3x of 6. I can also just take this number and divide it by this. Divide x to the 10th divided by 2 is x to the 10th. F looks a lot like C, right? We keep that negative out in front. I know the square root of 25 is 5, so I've done it. And then remember, we said if the negative is under the radical, it's no solution. There are no real numbers that you can multiply together to get negative 25. Negative 5 squared is positive 25. There is nothing that can give me a negative 25. All right, example 2 says approximate the square root of 5. Round to 3 decimals. So for these, we did not approximate, we found the exact answer, right? The exact answer is a whole number, right? Or a decimal or a fraction. Here, if I was to say the square root of 5, I don't really know that. I don't really know what exact answer, what exact number times itself would be equal to 5, okay? A calculator will give us a decimal. And if your decimal goes all the way out 9 places, 1, 2, if you have 9, you can infer, you can assume that it continues after that, and it might continue forever. And so what your calculator is giving you is an approximation or a rounded answer. Okay, so round to 3 decimal places. The square root of 5 is 2.236. Right? Those are 3 decimal places. Then remember, you always need to look at the number after. So it should be 0.6797. That's what my calculator will do, right? I know that 3 decimal places are the 2, the 3, and the 6. But I want to look at this one. If this one is a 5, a 6, a 7, an 8, or a 9, I need to add 1 to the final number. That I was rounding. Yeah, add 1 to this. So that would be 7. But if it's a 0, 1, 2, 3, or 4, you just stop it. Don't change it. Yeah. Leave a 6 as a 6. Oh, sorry. So the square root of 5 to 3 decimal places is 2.230. 3 decimal places means 3 place values after the decimal. Tens, hundreds, 10,000. All right. The next thing we will cover is the cube root. Yeah. When we see the cube root of a number, we are asking what number you multiply by itself 3 times to get this number. What could you raise to the 3rd power, right? It's similar to the square root, except that you can take the cube root of a negative. Okay. So the square root of 25. Ooh, sorry. Maybe not that right. The square root of negative 25 is no solution, right? But if I take the cubed root of, you could take the cubed root of negative 25, I'm just going to take the cubed root of negative 8, because I know it's a whole number. That will be a negative 2. So cubed root of negative 25 is no solution, non-real answer. The square root. The cubed root of negative 8 will give me an answer, because negative 2 times negative 2 times negative 2 will give me a negative. Negative 2
-2, that's -2, let's just solve that. -2 times -2 becomes a +4, but then I'm going to multiply that by a negative. A positive times a negative becomes a negative. So that is why, if it is an odd number here, you can have a negative underneath. Good. So a can be negative if this number is odd. If that number is even, a can never be negative. We just say no solution. Okay. If you have a TI calculator, your cube symbol will be under math. And then you can go down to 4 for cube, or you can type in a 3, go to math, and go down to 5, and it will put the 3 up there. Good. So if we did do -25, we would get a real answer. So that's what it means when it says A is not restricted to non-negative numbers. So A can be negative. A can be negative for cubes. For cubes, for fifth roots, for seventh roots, for ninth roots, any odd numbers. Okay. So we're going to find each cube root. Let me just write one. All right, my example will be 6 cubed is 216. Okay. -6 cubed is, yes, -200. There are 2 different answers for each of those. Therefore, the cube root of 216 is 6, and the cube root of -216 is negative. So let's find each cube root. And again, it's fine to use a calculator, but I just want to use the factor trees also so that we are sure we understand why this works. Good. So for 27, and remember for 3, because this is now a 3 instead of 2, we're looking for 3 factors to take outside the rest. So 27, the factors of 27 are, you divide it by 9, right? 9 times 3 is 27. 9 can factor into 3 and 3, and 3 is already prime. So 9 times 3 is 27. 3 times 3 times 3 is 27. So because I have 3 3s, I can take them out. So the cube root of 27 is +3. Because 3 squared equals 27. B, -125. The cube root of -125, I'll do 125 over here. 125 is 5 and 25. That's nice because 25 is 5 times 5. So now 5 times 25 is 125. 5 times 5 times 5 is 125. So that's 3. So I can take them out. Because it's a negative, let's carry that over because this is off. It can be negative. Okay. The cube root of 8 over 125. Well, I know 125 is 5, right? The cube root of 8, we also, sorry, the cube root of 8 we did up here. It's 2 times 2 times 2, right? Factor tree of 8. 8 would be 4 and 2, which would be 2 times 2 times 2, right? So the cube root of 8 over 125 is 2/5. The cube root of -8 would be negative 2, right? And then x to the 9. Let's do the x's again. That would be 9x. And instead of putting them in groups of 2, because it's the 3, I want to put it in groups of 3. Out of the 9, I got 3 groups of 3. So I'm going to say 2x to the 3rd. I can also say x to the 9th divided by 3 is x to the 3rd. So you can either just divide this number by this number, or you can think about how many groups of this size can I get out of this number. Okay? And if it was, let's do just a quick little side note, if it was the cube root of negative 8x to the 10th, yeah, I could still say, well, I'll do it again. So I would still have the negative 2, right? But now I would have 10x. I can still group those. And I'm still grouping them into groups of 3. 1, 2, 3. So I still have 3 groups of 3. But I'm going to rewrite this. Cube root of negative 8x to the 10th is negative 2x to the 3rd. And I leave that final x under the cube root. Still can't tell. Okay. Negative 2x to the 3rd cube root of x. So you can leave things under the radical if they don't come in groups of 3. Right, so after the cube root, we just call them the nth roots, like the 4th root, the 5th root, the 6th root, okay? And then we just want to talk about the rules that work depending on what the root is, okay? So the main rule is you can't take, and we know this, you can't take the even root of a negative number. So we know you can't do the square root of negative 25. You also can't do the 4th root of negative 25. Yeah? You cannot do this. It's okay to take the 3rd root of negative 25, but not the 2nd or the 4th. Okay? So when you are solving, you can cancel out the root and the exponent, right? If the root and the exponent are the same, then your answer is just the same, A. But if it's even, the A has to be within the absolute value bars, okay? If n is odd, it doesn't matter. It can be positive or negative, but remember, you can't take an even root of a negative number, so this number, when you solve, can never be negative. That's why the absolute value bar is an absolute value bar will ensure you never get a negative. Okay. So, sorry, I apologize. I wanted to make super clear. I was being very clear. So, super sure I was being super clear. If n is an even positive integer, then the nth root of a to the n is equal to the absolute value of a, because a cannot be negative. Okay. If n is an odd positive integer, then it does not meet absolute values bars because a can be negative. What do you say? A negative. Okay, so if I have let's say I have the sixth root of -5 to the 6th. Yeah. First, let's just do 6th root of -5 to the 6th. I get a positive 5. If I did the 6th root of positive 5 to the 6th, I'd also get 5. Okay? Why? Because -5 to the 6th becomes positive. Yeah. So it becomes the 6th root of 1, 5, 6, 2, 5. So that immediately becomes positive because we multiplied times a negative 6 times. 2, 3, 4, 5, 6. Right? Each pair makes a positive. And now, if I just take the 6th root of that positive number, I get a positive number. There's no way to get a negative number. It can only be a positive number. -5 to the 6th is positive. Yeah. Here, it will not matter. So here we can say, the cube root of -5 cubed is negative. That was okay. Because -5 cubed is a negative. And I'm allowed to take the cube root of a negative number. So I hope that's as clear. I hope that's clear. And basically, if the root and the power are the same, they undo each other. So now we're going to find each root. This is the 6th root, right? And so for the 6th root, if we're going to do a factor tree, we would need groups of 6 of the same factor, right? So for squared we need 2, for cubed we need 3, for the 4th root we need 4, for the 6th root we need 6. So 64, the factor tree is 64 until 6. We'll say it's 8 and 8, right? And then 8 becomes 4 and 2. 2 is prime, so we'll leave that alone. 4 becomes 2 and 2. 2 times 2 times 2 times 2 times 2 times 2. Multiply that all straight across, you get 64. 1, 2, 3, 4, 5, 6. So there are 6 2's. So I can say the 6th root of 64 is 2. Okay. Now let's do -32. I I can do a negative because it is odd, right? If it's an odd positive, sorry, if it's an odd root, it is not restricted to non-negative. So if it's an odd root can have a negative. You can take the odd root of a negative number. You can take the odd root of a negative number. You can't take the even root of a negative number. $32 is negative here, but it is the odd, 5 is odd, so it's okay. All right. So now I'm going to do the factor tree for 32, or a factor tree, I should say, because there are many ways you can start. You could have done 64 divided by 2. That would have been fine. Yeah. 64 divided by 2 is 32. So if I did a different factor tree for 64, it wouldn't change the end of my factor tree. 64 becomes 2 and 32. So I just bring that 2 down. Yeah. 32 becomes, let's just keep dividing by 2. 16 and 2. Bring that 2 down. 16 becomes 8 and 2, right? Bring that 2 down. Bring that 2 down. 8 becomes 4 and 2. Bring all the 2 down. 4 becomes 2 and 2. 2, 1, 2, 3, 4, 5, 6. Either way, I end up with 6. All right, so 32, I'm going to say is 8 and 4. 4 becomes 2 and 2. 8 becomes 2 and 4. 4 becomes 2 and 2. Bring these down to the front. So there are 5 2's in 32. The fifth root of negative 32 is negative 2. 16, 4. 16 is 4 and 4. And then each of those 4s becomes 2 and 2. So 16 factors to 4 2s, right? But it's negative 16. So I said, here for negative 32, negative 2, right? Negative 2 5 times will give me negative 32. 1, 2, 3. Yeah. 3, 4, 5. But here, if I wanted negative 16, can I do negative 2 4 times? No, so it's positive 6. That's why you cannot take the even root of a negative number. So this is no solution. There is no number you can multiply an even number of times and get a negative number. Okay. Example 5 to simplify. Assume that the variables represent any real number. Okay. So this is when we're going to use, we should probably have put this rule after example 4. All right, so example 5 is this, practicing this. If your root is even, you need absolute value bars because it cannot be a negative number. All right. So here we have 2, right? An understood 2. We have 4. We have a 5, and this is an understood 2. So I want to highlight the even roots. Okay. If it is even, it needs the absolute value bars. This one's even, this one's even, and this one's even. These need the absolute value bars when we're solving it. So 2, the square root and the square cancel each other out. Yeah. And I need to include the absolute value bars because it is even. So 2 and 2 cancel each other out. I get -4, but I need the absolute value bars because 2 and 2 because 2 is even. So the absolute value of -4 is 4. Good. Here, it's also even, so we're going to use absolute value bars. 4 and 4 cancel out. So I have absolute value of x minus 2. I cannot just change that to x plus 2 outside the absolute value bars because of the variable. So if the variable was 1, right? 1 minus 2, I would get -1. So if I took that out of the absolute value bars, I still don't know what x is, and so I don't know if my rule stands. It will always be positive, right? So if I just change it to x plus 2, saying, oh, there would be no negative, then what if x was -10? That could still be a negative. So we're just going to leave the absolute value bars because of the variable and the fact that I don't know what that variable is. It could be anything. So this one is 2x minus 7, and because the 5 is odd, we don't need that absolute value bars. So we just say it's 2x minus 7. Yeah. Good. Here we have 25x squared. Okay. The square only goes to the x. Remember the closest thing. We have 25. Square root of 25 is 5, right? The square root of x squared is x because those cancel each other out. But remember, we need those absolute value bars. So we can either say the absolute value of 5x or we can say 5 because that was just positive times the absolute value of x. Either one. Okay. So I don't know what x is, so I want to make sure it can never be. Now we're just using, we're practicing what we have learned about radicals by using radicals in a function, solving functions with radicals. So we've solved functions before. We use radicals today. Let's put it all together. All right. F of x is the square root of x plus 2. So f, what is f of 7, right? Take out the x, put in a 7. F of 7 is the square root of, no x, is 7. The square root of 7 plus 2. 7 plus 2 is 9. And the square root of 9 is 3. And again, it could be -3 or +3, but we are taking the principal square root, right? So when your calculator would give you, your calculator could only use 1. All right, letter B, f of 0, same thing, x plus 2, that whole thing square rooted, but instead of x, I'm just going to put in a 0. 0 plus 2, the square root of 0 plus 2 is just the square root of 2. And I don't know what that is. This, oops, the square root, no, the square root of 2 is 1.414242135. But I would just leave that as the square root of 2 because that's actually more accurate. 4, 1, 4, 2, 1, 3, 5, 6, 2. It implies that it's going on forever, right? It's a very long decimal, so I'm just approximating here, but this is an exact answer. So you could use the exact answer unless they ask you to approximate or to round your answer. All right, moving on to G. G of x is the cube root of x minus 1. So G of 9 is the cube root of 9 minus 1, which is the cube root of 8. And 8 is 4 and 2, which is 2, 2, and 2, right? The cube root of 8 is 2. G of 10, the cube root of 10 minus 1 is the cube root of 9, which is, I would leave it as the cube root of 9, but it is also approximated as 2.080083832. You just put it into your calculator. All right, and that is the end of 7.1. Thank you guys very much, and I will see you next time.